Okay, so standard enthalpy of combustion then. So we went through this a bit yesterday where I might just move the camera, where we could, where we could write an equation for a reaction that has the standard enthalpy of combustion of ethane. Again, it seems quite a wordy question, but that's how AQA are going to word it. Write an equation for the reaction that has the enthalpy change that is the standard enthalpy of combustion, formation, whatever it is, of ethane. So what was the important thing we needed to bear in mind when we were writing the equation? Someone else?
It was just 1 mole
ethane, yeah. We have to have 1 mole of ethane. So no matter how much you might want to put a number in front of it, we have to make sure that there's only 1 ethane in the equation, because if there was 2 ethanes, that will be twice as much energy, because if we double a reaction equation, you know, the balancing numbers in the reaction equation, then we double the amount of energy released. So there must only be 1 mole of fuel, whatever it is, ethane in this case. And just that reminder, enthalpy of combustion is always negative, and for a fuel is usually a pretty big negative number, usually 1,000, 2,000, 5,000. You'll see, you know, if you're burning octane, which is the main fuel in petrol, you're getting thousands of kilojoules per mole. That's why we keep putting it in our cars. Okay, so we did this yesterday, yeah? You should have this. Felix is just writing down rapidly, but I'll... we did that one as well, didn't we? Do ethanol? Seem to remember doing that as well. No halves needed there. Again, ethanol is used as a fuel, minus 1371. I say this because one of the things I keep trying to get across is whenever you're doing any kind of calculation, you get to the end and you ask yourself, what do you ask yourself when you look at your value that your calculator has spat out for you? Is it right?
Negative.
Well, you might not know if it's right. I mean, if you got the answer of minus 1371 for a calculation, you might not know if that's right or not, but you should be able to say if it's, what's the word I use? Reasonable. Is that a reasonable answer to that question? So when people are calculating, I don't know, you've done PV equals nRT, and you're calculating temperature, and you get a temperature for this gas which is, I don't know, 4 Kelvin. That's not a reasonable answer to that question unless you happen to be in space. 400 might be more reasonable, so maybe you've dropped a couple of zeros somewhere. So just having that question in your mind when you get to the answer it can be very useful. So if you're working at an enthalpy of combustion and you've got an answer to be plus 1371, and you know it's an enthalpy of combustion, you can look at that answer and go, hang on a minute, I've done something wrong. There's no way it could be a positive number. Okay. Did we do this, the Hess diagram bit? Is this new?
Yeah.
Okay, this is new. All right. So I'll just put this up here as well, just to show you how we get there. So I've got my reaction, which I think we used as an example for enthalpy change of formation as well. But now we're looking at combustion data. It's the data that matters, the data that you're given, which will determine how you work out the answer. Because it's combustion data, so I'm not forming these things from the elements anymore, I'm burning them. What do I make if I burn ethene, hydrogen, or ethane? What am I making? What do we always make when we burn hydrocarbons completely? Carbon dioxide and water. Okay, so down here I would have a couple of carbon dioxides and a few waters. Okay, so instead of the elements down at the bottom of my Hess diagram, it's now the products of combustion. And the arrows, and this is the really crucial bit, instead of going up, are now going down. Because we're making ethene, hydrogen, and ethane into carbon dioxide and water. Okay, arrows go down. And then I can put my numbers on. So minus 1393 would go there, minus 286 would go there, and minus 1561 would go there. And I'm just checking that I haven't got any balancing numbers in the equation that I might need to multiply by. No, I don't. That's fine. I can just use the numbers as they are. Okay. Can you just, using that diagram, using that data, can you work out an answer for delta H for that reaction, please? So yeah, so remember in our Hess cycle we're going from left to right, but via the products of combustion. So I'm going from this side kind of down this way to the products of combustion, and then I'm going up that way. So I'm going in the same direction as the arrows here, so minus 1393, minus 286, we can leave those as they are, but then going in the opposite direction to minus 1561. Which I think is all detailed on the PowerPoint as well. I will put this PowerPoint on the on Satchel, by the way, when we're all done. Okay. But sometimes people ask, in this case, it was Ali. Sometimes people ask, what did you just ask me?
There is no oxygen available.
There's no oxygen in our equation. How was I able to burn everything if there's no oxygen in the equation? So we do something that the mathematicians do on a regular basis. How many oxygens do I need? 2 O2s there and another 3, so that's 7 oxygens, isn't it? There we go. Okay. If we add stuff to left and right, it doesn't make any difference to the reaction equation, but there's your oxygen. Okay. Which of course we're gonna just not bother with for the rest of time. But yeah, it does exist, it is in there somewhere. Oops. Right. When we were doing delta HF questions, delta HF data, we were able to generalize this process and write a kind of general formula for solving problems. Can you write a general formula for solving problems when you're given delta HC data? Can you write a general formula that would help us solve all problems given delta HC data that would save us from having to draw complicated Hess diagrams? We'll just be able to stick numbers in a formula. If you can't remember what I mean, look back at your notes for the delta HF formula. Right. So mistakes on the PowerPoint if we're using delta HC data, the arrows are always going to be going down, and we're always going to be going from left to right for the delta H that we're working out. So we're always going to be going in the same direction as these arrows and the opposite direction to that arrow. So it's always going to be the reactants, and then we need to change the sign for the products. Reactants minus products. For delta HC data. Notice I put that quite large at the bottom there. Delta HC data. Notice that the C's are there. They're in the formula because we've been given delta HC data in the question. This is the point at which it starts to go wrong, I usually find, in this topic, which is why it's so appalling that my PowerPoint was wrong. Go on. Hey? Delta HR is the delta H for a reaction, whatever it is. That's what we're working out. That could be any kind of delta H at all. So the delta H, yeah, so it's up there. The delta H for that reaction will be reactants minus products. Yeah. The reason it goes wrong at this point is because what's the difference? I just pressed the button. Something happened. Let's press the button again. Ooh. Oh. What's the difference? Oops. The difference is if it's combustion data, it's reactants minus products. And if it's formation data, it's products minus reactants. Which is a nightmare, isn't it? Because that means if you're using the formula, it's very easy to get it wrong. And it gets worse because the delta H you're working out could be combustion or formation. So you could be asked to work out enthalpy of combustion for this reaction. So you're trying to find delta HC equals whatever, and you're given formation data. So you've immediately got both things in the question. You've got formation data, but I'm working out delta HC, which is it? Well, if you're given formation data, it's products minus reactants, because it's the data, which is why it's in massive font size, it's the data that determines how you work it out. So what you need to look at is not what the question asks you for, it's the table of data. What does it tell you? What information are you given? If you're not sure, draw a Hess diagram, because the Hess diagram will always have the arrows in the right direction. But if you want to use the formulae, plural, then you're going to have to get it right. Here is my handy method of remembering it. Let's get rid of my little revision timetable over here. Oh no, let's put it on. Okay. If it's combustion data, it's reactants minus products, and that almost spells crap. So this is the crap way of remembering combustion reactants minus products. Unfortunately, for par isn't much of a word, and that is the one you're going to come across more. If you look at the past papers, there's more questions on formation data than on combustion data. I'll explain why when we do more on delta H next in year 13. But that's my handy way to remember it. The crap way of remembering it is that combustion data is reactants minus products, but it's the data that determines it. Okay, having said all of that, let's just do some examples. Again, it's the data that determines how you work it out. Can you read that from the back there? Do I need to make that a little bit bigger? Is that all right? Yeah. For the benefit of the folks at home, I'll put it on the board as well. So it's 6 carbons and 6 hydrogens make C6H12. All right, using either a Hess diagram or the correct formula, can you work out delta H for that reaction, please? Yeah, these questions are typically 3 marks. The first mark, the way they put it in the mark scheme for this one, the first mark is actually forgetting the 6's into your answer. So they've given you a mark for noting that it's 6 lots of minus 394 and 6 lots of minus 286. And then the second mark is for putting the numbers in the right order in the equation, and the third mark's for getting the minus 160. I haven't seen that much before. I think this is a newer question as well. So you're getting credit for doing the thinking rather than doing the maths, which is probably how it should be for chemistry. Another one. State the name given to the enthalpy change represented by the following chemical equation. Explain why this enthalpy will be difficult to determine directly. We've had some experience of difficult to determine enthalpy changes. And then it gives you some standard enthalpy of combustion, standard enthalpies of combustion, and use the data to work out the enthalpy change. So it's 4 marks overall. I'm just going to say that again. It's the standard enthalpy of formation of carbon monoxide, because we're making carbon monoxide from the elements in their standard states. Why is it difficult to do this reaction? Because it's very hard to give out the oxygens one at a time. In the same way, it would be very hard to give out waters one at a time to copper sulfates. We can't make sure every carbon just has 1 oxygen. Some are going to get 2, some are going to get none. So it's difficult to prevent carbon reacting with O2 to form some carbon dioxide, is how they've worded that. To calculate delta H, well, it's delta HC data, delta enthalpy of combustion data, so it's reactants minus products, or a correct cycle, which gives us minus 110. Okay? One more? Or 2 more even. I can't remember how many examples I've got. There are several. So this is the kind of question that confuses students, because you're calculating the enthalpy of formation of propan-1-ol, and students hear formation and they go, oh, formation. It's products minus reactions. The data, of course, is combustion. It's the data which determines how you work out the answer. It's the data which determines which formula you use. That question I like to ask, is that a reasonable answer to that question? Trouble with formation data is it can be positive or negative. Combustion's always negative. But formation can be positive or negative, so, minus 316, is that a reasonable answer to the question? Yes. But if it was plus 316, then that would probably be pretty reasonable as well. You don't really have a lot of things to grab hold of when it comes to enthalpy of formation. We'll just do one more. One more, come on. You know you want to.
Right, yeah, in this one. It asks you to.
Hang on.
Yeah.
Those who are paying attention will have noticed it's an enthalpy of combustion reaction, but it's delta HF data. If it's formation data, it's products minus reactants. That's the formula you use. It's the data you're given that drives how you work it out, not what you are working out. Okay? Delta HF data, products minus reactants. Delta HC data is reactants minus products. And the answer is minus 2642. Is that a reasonable answer to this question? Yes, we're burning a big fuel, so yes, it should be a large negative number. Thanks, Jim.